Dear students, here I am welcoming you all to the online class of class 10 chapter 1 chemical reactions and equations. Today's topic is chemical reactions and equations. So in this chapter we are mainly going to discuss regarding with the what do you mean by a chemical reactions? How we can identify a chemical reactions? What do you mean by chemical equations? How can we represent a chemical equations? And how we can balance a chemical equations? And also we are discussing with the different types of chemical reactions. There we are mainly dealing with the combination reactions, decomposition reactions, displacement reactions, double displacement reactions, exothermic reactions, endothermic reactions, oxidation reaction, reduction reactions and redox reactions, along with a small part regarding with the corrosion and rancidity. So these are the main topic we are going to discuss in the chapter chemical reactions and equations. So from the topic itself we can discuss what you mean by a chemical reaction. Chemical reaction in a sense what? So as we know in our earlier classes we already studied regarding with the chemical changes. What do you mean by chemical changes? You may already know that. That is a changes in which new product formed is said to be a chemical changes. So the same chemical changes we can also known as chemical reactions. So a changes in which new product formed is said to be a chemical reactions. Or you can also define the same chemical reaction in another manner. That is the transformation of chemical substance from one to another. What it is? The transformation of chemical substance from one to another. We can call it as chemical reactions. Chemical reactions. So let us check with an example from your textbook itself. Magnesium reacts with the oxygen to form magnesium oxide. That means 2Mg reacts with oxygen to form 2MgO. This is a chemical reaction. So in this activity which is describing that, take a magnesium ribbon. You have to rub this magnesium ribbon with sandpaper. So why we are rubbing the magnesium ribbon with the sandpaper? Because there are certain impurities as well as the oxides of magnesium may be present over the magnesium ribbon. So to remove this oxide, so suppose if the oxide is present over the magnesium ribbon, can prevent further action of magnesium with the oxygen. So you have to rub with the sandpaper to remove the impurities as well as the oxides of the magnesium. Got it? So next, once and hold this magnesium ribbon with the tongs. Tongs is a equipment or a device which is use the chemical lab to hold the chemical vessels. Different chemical vessels you can handle or hold it with the help of a thumb. So you have to hold this magnesium ribbon with the tongs, and you have to burn it with the help of a burner. You have to burn this magnesium ribbon with the help of a burner. While you are burning what you are observing. So these experiments you have to do with the carefully, because you are burning with a burner. So you are playing with the lights or playing with the flames. So it will be, you have to deal with very carefully with the help of the teachers, assistants only. You have to do this activity. So here, don't practice this in your home. So okay. Then during this activity you can see a dazzling white flame. What it is? Dazzling white. So what do you mean this dazzling white flame? Dazzling white flame. Dazzling white flame. Dazzling white flame. You can observe a dazzling white flame. That means a bright white flame. So suppose for example, if we look at a bright light, our eyelids will be closed. Similarly, you can observe a sudden dazzling white flames. So during these reactions, while burning magnesium, you can observe a dazzling white flame. This is, during this reaction you can see this magnesium is converted into some other product, that is some other substance, that is to magnesium oxide, that is magnesium oxide will be formed during this chemical reaction. So there is a transformation of chemicals from one form to another form. So we can say it is a chemical reactions. Got it? So next we are going to discuss how we can identify a chemical reactions occurred or not. So many changes which are occurring in our daily life. So many things are there. So for example, if you drop a glass, it will be to the floor, it will be once it with the sounds, it will be break the glasses. So another one, so baking of food, ripening of fruits, or rusting of irons or metals. So these all things we can see some kinds of changes, but we don't know whether it is a chemical change or whether it is a chemical reactions or not. So we are unable to identify. So for that, we can identify whether a chemical reaction is occurred or taken place or not by certain observations. By following certain observations, we can identify whether a chemical reaction is take place or not. So what are the observations we are used to follow, or what are the process which is involved during a chemical reactions? So we will discuss one by one. So the first one is change in stage. The process which are involved during a chemical reaction. First one is change in stage. First one is change in stage. Change in stage. And second one is change in color. Change in color. Change in color. And third one is change in temperature. Change in temperature. Temperature. Change in temperature. And fourth one is evolution of gas. And fourth one is evolution of gases. So these are the certain observations we can see or we can identify in a chemical reaction. If you observe any kind of these changes in a or any kind of observation in a changes, we can say that, we can state that it is a chemical reactions. So we will discuss one by one. First one is change in state. So first I will discuss with an example. I will be explain change in state. So as we know, matters are existing commonly 3 states, but we are saying 4 states. So generally 3 states. What are there? Solid states, gaseous states, liquid states. So these are the 3 states. Plus plasma states. Now we are introduced. There are 4 states. Okay. Mainly 3 states. What are there? Solids, liquids, and gaseous states. So here, first one is change in states. For example, hydrogen reacts with oxygen to form water. Hydrogen reacts with oxygen to form water. Here in this, hydrogen is in gaseous form. Oxygen also is in gaseous form. And you are getting the products, you are getting the new substance which is in liquid state. So we can clearly identify from this equation what it is. There is a change in the states. Here you can see hydrogen is in gaseous state, oxygen is also in gaseous state, is changed into liquid states. So it is an example of what? Change in states. So if any changes in states happen during a chemical reaction, we can say it is a, or any changes we can say it is a chemical reaction. So second one is, second part, change in color. Change in second way we can identify chemical reaction is change in color. Changes in color. Change in color. So, one example I will discuss here. So, lead nitrates, PbNO3 twice. Lead nitrates, which is colorless. Lead nitrate is colorless. Lead nitrates react with potassium iodide. Lead nitrates react with the potassium iodide. Potassium iodide is also colorless. Potassium oxide is also colorless. So the reaction of two colorless compounds, that is lead nitrates with the potassium iodide, you will get the new substance. You will get the new substance, that is lead iodide, PbI2. Lead iodide, which is yellowish in color. Lead iodide, which is yellowish in color. Plus along with you will get KNO3, potassium nitrate. Potassium nitrate. So you have to balance the equations. 2 plus here 2. So these are balance equations of this chemical reactions. So we will discuss balancing the chemical equation. Will be discussed next upcoming classes. So now we are discussing change in color. So in this equations you can see potassium nitrate, which is colorless. Lead nitrate, which is colorless, and potassium nitrate is also colorless. These two chemical substances undergoes chemical reactions. We get a new products which are lead iodide and potassium nitrate, which is colorless, but it is precipitating, and lead iodide, which is yellowish in color. So you can see colorless substance is changed into a colored compound or a colored substance. So change in color. So third one is, you can identify chemical reaction by following. Third way, that is change in color, and third one is evolution of gases. Evolution of gases. Third one is evolution of gases. Evolution of gases. Evolution of gases. For describing this, there is an activity which is mentioned in your textbook. For example, take a conical flask. Take a conical flask. This activity there are mentions in your textbooks. Take a conical flask. Keep something granules in this conical flask. Keep something granules in this conical flask, and you have to cover with a stopcock which inserted with a tube. This is inserted with the tubes. This is a setup you have to arrange in this chemical reactions. Okay. In that you have to add sulfuric acid or hydrochloric acid. So you have to add drop by drop what? Drop by drop. Either you can add what? HCl or you can add sulfuric acid. HCl means hydrochloric acid, sulfuric acid, H2SO4 in a sense, sulfuric acid. So you can add to this. So while you are adding, you can see in the bottom you can observe what? In this bottoms you can observe exactly the term is brisk effervescence. What you can observe? Brisk effervescence. You can observe brisk effervescence. Effervescence you can observe. What do you mean this brisk effervescence? You can see as like a bubbles. Bubbles are coming like that. You can observe on the bottom of this conical flask. These bubbles indicating what? It is nothing but hydrogen gases. This hydrogen gases will come out through these tubes. So you can easily identify whether any gases are coming or not. So if it is hydrogen gas, you take a burn candle so nearest to this. This hydrogen gas will be burst out as like a pop out sound. Hydrogen gas will be burst out as like a pop out sound, as like a balloons. How it is burst out in similar manner, this hydrogen gas also will be burst out. So we can easily identify that the hydrogen gas is generating during this chemical reaction. So I will be mentioning the chemical equations here. What it is happen during this chemical reaction. So here you can see zinc. Zinc reacts with the, suppose if you add sulfuric acid, you will be get H2SO4. Zinc reacts with the sulfuric acid, you will be get zinc sulfate. ZnSO4 plus H2. H2 is in gaseous form. H2 is in gaseous form. So what it is? Evolution of gas. So during these reactions, you can find out there is a formation of gas. See, it's clearly stated that there is a chemical reaction is occurred. Then if you are using, suppose if you are using instead of sulfuric acid, if you are using hydrochloric acid, you can say zinc reacts with the HCl, you will be get zinc chloride, then Zl2 plus H2. Here also you can observe what it is, hydrogen gas is generating. So evolution of gas. So we already discussed change in color, change in state, and last evolution of gases. And the fourth way we can identify a chemical reaction is change in temperature. Change in temperature. Change in temperature. So the fourth way we can identify a chemical reaction is change in temperature. Change in temperature. Change in temperature. So, just previously I mentioned the reaction of zinc granules with the hydrochloric acid or sulfuric acid. During that reactions, if you touch the conical flask, you can experience that the heat is generated. Heat is generated. Next we are going to discuss regarding the chemical equations. Chemical equations. So, what do you mean by a chemical equations? What do you mean by chemical equations? Do you have any idea? What do you mean by chemical equations? So we can say chemical equations means it is a simplified way of representing chemical reactions. What it is? Simplified, easy way. We can say simplified or easy way of representing chemical reaction is called what? Chemical equations. What do you mean chemical equations? Simplified way of representing chemical reaction is called chemical equations. For example, you consider a symbol. For example, first example, the magnesium react with the oxygen to form magnesium oxide. This is the chemical reaction. So how elaborate? How too big it is? So same chemical reactions we can represent by chemical equations. Chemical equations. So as we already know, every chemical reaction consists of two parts. What are there? Every chemical reactions consist of two parts. What are there? Reaction consists of two parts. First one is reactants. First one is reactant sides and second one is products. One is reactants and second one is products. These are the any chemical reactions consist of two parts. One is reactant side and another one is products. I hope you may already know what you mean by reactant and what you mean by product. So reactant means the substances which are undergoes in a chemical reactions. We call it as reactants. And product means the result of a chemical reactions. We call it as products. For example, a simple examples I will be mentioned here as from your earlier textbooks. That is, magnesium reacts with the oxygen to form magnesium oxide. Magnesium reacts with oxygen to form magnesium oxide. So in these reactions, we can say magnesium and oxygens. These two are undergoing what chemical reaction. This is called what? This is called reactant. This is called reactant. And here you will get a new product. This is magnesium oxide. Magnesium oxide. This is the product. This is the product. Got it? So for writing a chemical equations, we have to remember these reactants and products. You have to remember the reactants, how we have to write, where we have to write, I will be explained now. So now we will discuss with the chemical equations. So chemical equations we can write by two ways. Two ways we can write chemical equation. First one is word equations. First one is word equations. First one is word equations and second one is symbolic equation. Symbolic equations. First one is word representation or word equations and second one is symbolic equations. We can write chemical equation in two ways. One is word equations and second one is symbolic equation. So first we will be discuss what we mean by chemical equations which is in word manner. How we can represent a chemical reaction which is in word manner or word ways. For example, previous example we can take. That is magnesium react with oxygen to form magnesium oxide. So same equations if you are considered here, you can write magnesiums react with that's reactants added together with the help of a plus signs. Reactant added together with the help of a plus sign. So magnesium react with oxygen to form magnesium oxide. Magnesium oxide. This is the chemical reaction. So in these chemical reactions, you can observe magnesium and oxygen. These two are in where? These two are in reactants. And this one is magnesium oxide is a product. Magnesium oxide is a product. This is by using words. That whole equation, right? Instead of writing that whole way, we can write by using in this manner by using words. That is magnesium reacts with the oxygens. That means these are the reactants. That reactant added together with the help of a plus signs. And the products. What is the products we are obtaining? Magnesium oxide. Magnesium oxide is the products we are getting. So in these chemical reactions, if suppose more products are there also you can use plus points. There you can also use plus point to add more equations. More products if it is there, you can use plus points. Then same word equation we can write in symbolics by using symbols. Here magnesium reacts with oxygens. Magnesium reacts with oxygen to form magnesium oxide. Magnesium oxide. This is by using symbols. Magnesium is represented by Mg, oxygen is represented by O2, and magnesium oxide is represented by MgO. So by representing by symbolic, we can represent the chemical equation. So most commonly we are using a symbolic way of representing a chemical reactions. So next class we will discuss how to balance a chemical equations. So next class we will discuss how to balance a chemical equation. So today we have discussed mainly regarding with what do you mean by chemical reactions, how we can identify chemical reactions, whether it is occurred by changing state, by changing color, by changing temperature and evolution of gases, and what do you mean by chemical equations, how we can write a chemical equations, that means the word equations, and by symbolic representations. Thank you.